Have. All
Are we
right.
live?
Yeah, we're live. All right. Welcome to UAB Data Science Club. I don't know which number it is. I've lost count. But here we are another week. And we've been playing around lately with this thing called Streamlit to make data science dashboards with because, you know, it's great to do the analysis that we want to do. But if we can't turn around and provide that analysis and that data to somebody else, then it's not really, that useful. So Streamlit is a very simple Python library for creating a web dashboard, and it can take in and use like pandas data frames and Seaborn and Matplotlib charts. It's very similar to the R-Shiny applications. So what Ravi has done is taken this Streamlit library and then used the New York Times data for the COVID-19 spread that they keep up to date in a thankfully in a Git repository, and then basically recreated a simpler version of the New York Times dashboard for checking on coronavirus cases in the US.
Yeah, so basically the New York Times dashboard it looks like this. You'll see it has a map of the hotspots in the US currently, where new cases are increasing, mostly the same, decreasing, and then there's a sort of a data frame kind of a view over here that how many cases are there per 100,000 or stuff. So our dashboard isn't that fancy yet. We don't have the text in between and not that many sections. So after cloning the repo that we have created with Streamlit, you should have a dashboard that looks like this. It's going to show you US trends. So total number of cases. So you'll see for June 23rd, we have 2,357,209 cases. And then deaths are, on 22nd, it was 120,346, and 23rd, it's 121,178. And you can check your local trends over here as well. You can select your state. So if you wanted to just check how is Alabama doing, you can just select that, and don't select any county. If you keep it as all, it's checking the entire Alabama. You can see the trend over there. You see that the death graph has gone up in the last day. It seems like an uptick over there. And if you just wanted to check your Birmingham area, Jefferson County, you can check that too. And you can see how the total cases and the total deaths are growing in your particular county. Then you have, let me change this to all. And then you will get a map where you can check for this particular date, how many counties were affected in the state that you selected above. So like on 11th, there wasn't a single case in Alabama. So you don't see anything on the map, but let's see, I think 13th or 14th, we started having cases. Let me go to 15th. And you'll see that on 15th, there were 8 counties that were affected, and Jefferson was one of them. And similarly, you can just keep increasing and seeing how it actually spread around in Alabama. So this is the map that you should be able to, this is the dashboard that you should be able to get once you run through the steps that we mentioned in today's session. So like William mentioned, Streamlit is very useful to actually show the data to the end user. Like he mentioned, it's not useful if you do wonderful analysis, if you make wonderful graphs, but there is no method of showing it to the end user. And that's something that data analysts have to do. They have to create some sort of app, very simple app. It doesn't have to be very complicated, but it needs to show the things that you have analyzed to the end user. For a long time, people were using Flask because Flask it's not that difficult, but it's not as simple as Streamlit as well in actually showing you these web apps. And Streamlit is built for showing for actually showcasing the analysis that you have done with datasets. So it generally just works with pandas and stuff. If you're thinking of making something very, very complicated with Streamlit, I don't think with its current capability, you would be able to do that. But a lot of these things you should be able to do.
Yeah.
So
if you're like me in the thought of making a website to show off your data sounds like a scary proposition, Streamlit basically takes care of a lot of that stress.
Yeah. And so our repo is in gitlab.rc.ub.edu/ravi89/NYT-COVID-dashboard. I think William has the link for all these repos that are open in the chat. And you'll also find a link for Streamlit, where you can find more things than what we have included in this repo. So you can also show your data set like New York Times is doing and all this stuff. And the data set, like William mentioned, the data set that we are using is New York Times data set. Specifically, the data set that we are using is uscounties.csv. You also have usstates.csv and us.csv. We haven't looked into these. So if you want to change around the repo that we have, the new NYT COVID dashboard with these data sets, feel free to do so and see if you can generate more things or less things or present it in a different way. This is one method of presenting. I would say after working with Streamlit on 2-3 projects, I think the most important thing that I've noticed is taking the initial half a day or so, just trying to design your dashboard, just so that you know that these things should go over here. You need to have text, a bit of text over here. You need to have this graph. You need to keep these choices to people to actually manipulate the data sets. That seems like something a lot of developers shy away from, the design process, but I think it would be extremely useful. Because once you start doing these things, you suddenly run into, oh, should I add this graph as well? Or should I add this graph as well? And then you're just doing analysis for sure, but it would be a little directionless. So to get that direction, it might be worth spending half a day just trying to design your dashboard on a piece of paper with a pen, just seeing that how the dashboard should look like. All right. We will go through a bit of the code. We are not going to go into extreme depth of the code. Feel free to read through it and ask us questions, either right now or come to our office hour sessions where you can ask questions about this repo. But basically, the first thing that you need to do is when you are cloning this repo, do a recursive clone, because this folder, this directly links to this New York Times COVID data set. So when you do a recursive pull, it's going to pull this Git repo as well. So the New York Times data set as well. If you don't do it, you'll have to go, if you just do a normal Git clone, you'll have to go into this directory and pull this data set as well.
Yeah, and the nice thing about that repository there is that has, that's the repository that the New York Times is using to keep their page up to date. So it has the data, the most up-to-date data inside that repository generally.
Yeah, yeah. And once you have done the clone, you can create your Conda environment using this environment.yaml file. If you don't know how to actually create a Conda environment from environment.yaml file, we do discuss it in, I think, in our very first video, how you can create a Conda environment. Or you can just search for Chiha Anaconda, and that should be the first link that shows up. And it would be create a virtual environment using environment.yaml file. And you should be able to create your environment using this command. And once you have done that, you just need to run Streamlit run code dash, because that's the main Python script from which the Streamlit app is going to be running. And you'll see that it's running over here. Basically, I use Streamlit run code dash.py. All right, so let's start with the code dash, and we'll go to other Python scripts, because just to keep the project clean, I've created multiple scripts, and there are functions within those scripts which I'll be calling from this code dash.py. And this is the main one where the Streamlit commands are going to be running. So we need Streamlit. I'm copying it as or importing it as st pandas config. So config is nothing but this file. And there I define the database that I'm going to be using. So I'm using the uscounties.csv. So if you want to use US states, you just need to change this. Just keep in mind that you might need to change more things in Codash and funklib, because the analysis that I have done is based on this data set, not on US states. So there might be some things that are missing in US states, or there might be some things that are they're more in US states.csv. Basically, if you want to look, uscounties.csv looks like this. So on this date, in this county, Snohomish, Washington State, FIPS is basically, from whatever reading I have done, it's a unique identifier for a county. So for this FIPS, there was 1 case and 0 deaths. On 22nd, again, Snohomish, no other county. 23rd, just this. And I don't know how much news you guys have followed, but initially, if you will remember, it was the Washington State where the COVID outbreak started happening in, I guess, a nursing home or something. I'm not completely sure about that, so don't quote me on that.
Yeah, I'm not sure, but I do remember Washington State was one of the early hotspots.
Yeah. And the second thing that you'll see, so there's a default date for map. So if you come over here on the Streamlit dashboard, you'll see that the first thing that showed up over here, that was the default date, that was 11th. So for instance, if I change this to, rather than 0311, I'm going to use it 0411. And let's see, I don't know, I don't think I need to restart this, but yeah. So you see, as soon as I change my default date, the default date that it shows is 0411. But it's not like it's not changeable. It's just the first thing that will show up over here. I chose 11th because that was the date when I think 12th or 13th was when Alabama started having some cases showing up, right? So I just chose 11th so that you can see the trend in Alabama, since we are from Alabama. And there is this DBF file. This was needed to actually plot the maps, because I needed a geographic center of each county. And this DBF, that is database file, actually gives me that latitude and longitude data that I need to actually plot it on a map. All right, so the first thing that we do, so we have config, we take date time, NumPy, we get insert. And from funclib, that's a function that we have created. We get all these different functions. We get coordinates, get data, get county key, get state key, filter data by county states, and from graphs, drawing all these graphs. So the first thing we do is we need to get the data from that CSV file. So we call this get data function, and you'll see we are getting this get data from funclib. So let's see. So here is get data. So it basically goes, it reads the CSV file from our, whatever was the DB that we specified in our config file. And then we convert it to datetime, the date function especially, so that we can actually perform some functions directly on dates. And then we return a data frame that gets saved into COVID data. Then we use Streamlit for the first time, and we add a title to the page, COVID dataset. You'll see that's the title that shows up when you use just st.title. Then you have st.header, US trends, and that's this US trends. And then we want to draw these two graphs. So draw total cases graph and draw total deaths graph. So these are, so total cases graph is we give the data frame that we just created when we get data. We group them by date and check the sum of all the cases. And then we just write streamlit.write total cases for US, and then we just do a line chart. And Streamlit has a function of drawing graphs, and one of them is line chart. And you just draw a line chart for this total cases by day. And similarly, total deaths graph, but you are just counting or summing up the total deaths over here. And that will give you these two graphs over here. The second part is a bit trickier, where we want to get the local trends. So we want the people to be able to select which county they are in, which state they are in, or however they want to actually select. So so the first thing that we want is we want to get coordinates as well, because we want to plot them on a map based on what people have selected in the choices that we give. So we are going to get another data frame called COV_CORD. And for this, we need this, we are using this get coordinate function. And you'll see it over here. So we get the FIPS data. That's somewhere over here. You get the FIPS data set. You merge that data frame. And all these functions are somewhere over here. So you should be able to take a look at them. You clean the data frame, where you drop all the ones where there is NA. You drop all the rows where you see some not a number kind of entries. And you also rename some of the columns from from uppercase to lowercase, because that's something that's needed by the Streamlit map. So they can either be complete longitude or lowercase LON. And then basically you just return that clean data frame, and you have it in COV_coordinate. And you add another header, local trends. So now we want to get state keys. State key is basically just getting however many, what all states are there that we need to give people as an option. So like, for example, if you select this, you'll see that all these states are showing up over here. So there are two methods. Either you create a list on your own where you actually name all these things, Alabama, Alaska, Arizona, Arkansas. But being a developer, we are generally pretty lazy. So rather than typing it all ourselves, what we are going to do is we are going to use this data frame to actually give us those unique values in that state column. So get state keys, I think it's still here. One thing that I forgot to mention is this @st.cache. That basically what it does is it saves that data frame in the cache of your browser. And what that basically does is it speeds up your app that you are, or Streamlit app. One thing that you have to keep in mind is that the things that you keep in cache, don't try to change it after the fact. So if you want to change some things, it might be better to have a new copy of the data frame rather than changing the original one. Because in cache basically means if you're changing it, it needs to reload that thing again. Then you're losing the benefit of keeping them in cache. All right, so get county keys and get state keys are pretty simple. So you, from the data frame that you pass over here, you go to state column and you find the unique ones and you sort them, because we like to see it's Alabama, Alaska, and all those things. They are sorted out correctly. And then you get county keys based on the state, so that if the state is equal to the state that you have passed, only then calculate that county. So that when I'm choosing Alabama, I only see the counties that are there in Alabama and not the entire country. And so basically, if I choose Alabama, it will change this, and you'll see that all these counties are just there in Alabama. So there is Tuscaloosa, Montgomery over here. But as soon as I change this to, let's say, Georgia, you'll see there is Fulton County, but there is no, I don't think there is a Jefferson in Georgia, is Montgomery in? Is there a Montgomery County? I don't think so, but.
I don't know, I don't think so.
Yeah, but basically that's what we were doing over there. All right. So once you have these keys, I also wanted to add another one called all, so that you can have an option where you can choose the entire thing. Because you might want to see trends just for Alabama, where you want all counties to be there. So it's better to give an option of all as well. And I'm using that NumPy insert function to add it to the 0th index, this all value. And then you use the select box from Streamlit, and you select your state, you specify that state key that you just generated, and that's how you see all those states. So whatever state that people choose, that gets passed to this variable. And similarly, whatever county that people use, that gets passed to this county variable.
Yeah. And I just checked, there is a Montgomery County in Georgia.
Okay, so there might be one over there. It's just difficult to see, actually. Let's see. One of the advantages is that you can type. Yeah, so there is Montgomery in Georgia. I don't think there is Jefferson, but we can. Oh, there is Jefferson too. Interesting. Alabama doesn't have Fulton. So you won't find Fulton over there, but in Georgia, there is a Fulton.
Well, I don't think there's a Tuscaloosa County in Georgia.
Georgia. Okay, so yeah, there is no Tuscaloosa. All right, and basically, so you create a new, since we had those things in cache, we are going to create a new data set that's going to be the filtered data set by county and state that people chose. So you chose the state and county. We are going to pass this to this function, filter data by county state. You go to filter data by county state. So if people chose all and all, then return the entire data frame. If people choose county as all, then just county as all. So it's going to go from top to bottom. So first it's going to check this condition. If everything is all, it returns data frame. If only county is all, it returns the data frame where the state is equal to the state that people have chosen. If it's state is all, then county thing. And if both of them have a value other than all, then it's going to check both these conditions and create a new data frame. So you have that new filtered data set over here. So the second thing is just to check if it's not empty, because if it's empty, you don't want to draw anything, because it's going to just show that, oh, this is not valid because there is nothing over here. So just I'm putting again an if condition. If this is not empty, which it should not be after all anyways, but you can draw your county state cases graph, draw county state deaths graph. So that's basically these two. So you pass the county state and the filtered data set over here. So this is in graphs. So draw county state cases graph. Basically, you again group by date and cases and sum, you group by date and then you sum that cases variable and then you just draw that line chart. And similarly, the deaths thing, but you're using sum on that deaths column. So you draw these two graphs. Then we need to draw this. And so let's go over here. And then you check date to filter. And basically you get a date input. So you check for date, that's the text that you see over there. You have a config. We created a default date for map in our config. And that's what we are basically using over here, but we are just, stripping it in the form of datetime function so that it can actually match what's there in the data frame. So if you remember the first time we got data, we actually converted that date column into a datetime, what's those things called?
Format?
Yeah, datetime format. And so similarly, we are converting that default thing that we gave over here. That's why it just shows the default time over here. And then you draw a map based on the filter data set, state, county variable, and date to filter variable. And else, if this one was empty, then it's just going to show this combination is invalid. So based on the changes that I made later, I don't think it should reach over here, because that was only possible if I chose Georgia and I hadn't limited the counties just to Georgia, and if I used like Tuscaloosa, like William mentioned that Tuscaloosa is not available in Georgia, then there would be nothing for this combination, Tuscaloosa County and Georgia State. So everything should go off there. But since we have limited our counties to only be the ones, to only show the counties that are available in that state, I don't think we should reach that condition over there. Feel free to try to get to this stage where you create a combination that is invalid. I think after the changes that I made over there, I think it might be not be possible to reach over there. But it's still good to keep a fail-safe check kind of thing, where in case you actually do create it, you have a condition where it can go and be like, oh, this combination is not valid. All right, let's take a look at this map thing. That's the last thing that we drew on this Streamlit app. So we are getting a data frame, state, county, and a date. So we want this, we create a new data frame just for this particular date. And then we draw a map, because we already had latitude, longitude values. If it sees those columns, its st.map is going to draw it automatically. And then we just basically write how many counties got affected. So if you find out the length of this, then you can see these many counties were affected on this day with this filter. And then total deaths in whatever you have selected and total cases. So basically, like if I choose all of Georgia, you'll see that 162 counties were affected in all of Georgia, and total deaths in Georgia on this date were 434 and cases were 11,196. If I change this to March 25th, you'll see that only 101 counties are affected, 33 deaths and 1,245 cases. So this will keep changing based on how much you're changing over here. Yeah. And that's basically it. So it's not a lot of analysis that I'm doing, but Streamlit makes it pretty simple to actually create a data app where you can actually create something for the third-party user, for whoever you are actually analyzing the data. And you don't have to worry about Flask or any of the other web server things over here.
Yeah, and when you're running this, by default, this is just running on whatever machine you type, the
the stream
command, the Streamlit run, and then the name of the Python file. So unless you have it set up on a server or on an AWS or Azure instance of some machine that's network facing, you're not going to be able to access it from other machines.
Mm-hmm.
But that's something that you would then talk to, you know, your local IT person about how to get that connected out to the universe so that other folks could see it.
Yeah.
Other than that, I guess the other question is, so when developing something like this, would you recommend, Ravi, that people start straight with trying to create the Python structure of their code, or perhaps go first into like a Jupyter notebook, get all the charts that they like, and decide what analysis they want in the app first, and then just kind of copy and paste that code into their Streamlit app?
Yeah, that's a good point. I think Jupyter initially might be better. Keep in mind that I have used a lot of line chart, Streamlit line chart, but Streamlit does support Seaborn and Plotly as well. So all the pretty maps that you can actually make on Plotly and Seaborn, you can actually display using Streamlit. But Jupyter Notebook might be a better place to actually create those graphs so that I guess you're more familiar with the thing, and you can make changes easily in Jupyter Notebook. So for development purposes, Jupyter Notebook might be a better place to start with.
Well, so another thing that's probably important to note, that when I was playing around with Streamlit, is that if you change the underlying Python code, it goes ahead and makes that change automatically on the dashboard as well.
Yeah. So like this thing is running. Let me try to. So like suppose we wanted to actually print out this filtered data set, right? So I'm just going to add one line, sc dot right. And I'm going to save it. Let's see. Reload.
Yeah, it's running. I see it up there, those icons moving all around.
Yeah.
Up in the upper right, it says running.
Yeah. And you'll see that, so now since we have selected all, it's writing the entire data set version. You'll see that there is longitude and latitude values as well, and the fifth value. And suppose we just selected Alabama, you'll see that it's only Alabama state that's showing up. If I just wanted Jefferson County, I can limit that too. So now only county of Jefferson and Alabama state are the values that I can see. So on 13, 2 cases, 14, 6 cases, 15, 13 cases, and all those things. Generally, this might also be useful if you're just testing things out. This is okay. I generally, eventually, once you have these graphs and stuff, you don't necessarily need to show the data, but I can understand in some cases it might actually be useful as well. Because even in this case, it might be useful to see what was happening over here on all those days.
Yeah, that's cool. All right. Well, thanks, Ravi, for taking us through this. And like we mentioned earlier, we've posted in the chat for this video the all of the links. So the original New York Times dashboard, as well as the code for this dashboard that Ravi put together. So you're welcome to clone that repository, play around with it, and see what you can come up with. maybe even switch out the data, try something different, or do more in-depth analysis to.
Yeah, I might add some instructions. I don't have a README file over here, which I should, but I'm going to add a README file over here just so that I can add those recursive get clones and how to create this environment YAML file or conda environment using this file and how to run it. But one other thing that I might just mention, once you have cloned this, you have one particular data set. Just to update it, just go to this COVID-19 data, do a git full origin master, and then go back and then run it, and you will have the latest data set. So suppose if you cloned it initially on today, and after a week, you just try to run that thing again, you will still have the data set for still today, not for the next week. So on that day, you can just do these 2-3 things, go to that COVID-19 data, pull origin master, so you have the latest data set, and then basically just run Streamlit, run again, and you'll have all the data sets that's available, or the latest data set.
That makes sense. That makes sense.
Yeah, and feel free to use this. I think this is a pretty nice app, and it's very nice to show other people the analysis that you're working on, and this might be the easiest method you can do it. There is also that, what was that R library that you discussed earlier?
R-Shiny?
Yeah, R-Shiny. R-Shiny is also, I've heard, pretty good. I haven't had a chance to work on it, but maybe next time we might talk about how you can draw something similar on R-Shiny as well.
Yeah. Yeah, no, that sounds good. That sounds good. All right. Well, if you guys have questions, feel free to hit us up in office hours or shoot us a message or something. But other than that, we'll see you guys next time.